Ah, I'll check the live stream as well, out of curiosity.
Right. Okay, everyone. Thank you for joining us today for the University of Texas Energy Symposium for November 7th, 2023. I'm Kerry King, Assistant Director and Research Scientist at the Energy Institute at the University of Texas at Austin. Before I more formally introduce our speaker today, Steve Keen, I will point out the next two upcoming talks. These are the last two talks for the fall semester for the year 2023. Next week, we will have Dan Earhart, CEO of Arcus Power. He'll talk about AI, artificial intelligence, and short-term power trading. His firm collects data on electricity markets and creates tools for people to understand how to operate and use their assets in the electricity markets. And then the final talk, November 28th, which will be 3 weeks from now, will be a conversation with myself and the CEO of X Energy Clay Cell. X Energy is a company developing small modular nuclear reactors, including with plans to install them at a petrochemical facility in Texas as one of their first demonstrations. So we'll have end with a talk on nuclear. But today it's my pleasure to invite Steve Keen, Professor Steve Keen. For those of you who might know him, he has been a critic of mainstream economics for over 50 years, specialized in developing genuinely dynamic methods for economics, especially as applied to analysis of money and energy, two topics that mainstream economics routinely ignores, as he will discuss. His most well-known works are Debunking Economics, a book from 2011, as well as The New Economics, a manifesto from 2021. He's invented an open source system dynamics program called Minsky, whose, quote, godly tables enable dynamic monetary models to be developed using double entry bookkeeping. He supports himself via crowdfunding largely, and he has a Substack account as well. The abstract of his talk today, economics went astray from the path towards biophysical realism in 1776. So since the beginning of the US, with the publication of Adam Smith's Wealth of Nations. This has culminated in today's neoclassical economic analysis of climate change, which is, as he says, utterly delusional and also highly influential. Fossil fuel industries may have waged the war against action on climate change, but the weapons of mass destruction they have wielded were crafted by neoclassical economists, commencing with William Nordhaus's, as he said, uneducated dismissal of the limits to growth studies from the 1970s, and culminating in an economic orthodoxy which sees a trajectory towards 7 degrees of C of warming, if that were to occur within 2 centuries' time, as reducing annual economic growth by only 0.02%. So with that said, I will now hand it over to Steve Keen. Please submit your questions via the question and answer feature as we go along, and I will try to interject the questions to Steve. Otherwise, we'll try to take them at the end. But Steve, feel free to share your screen, and the floor is yours.
Thank you very much, mate. Great introduction. All right. Now I'm calling this is a generic, modified generic presentation about correcting how wrong economists are on energy. And Kerry mentioned my crowdfunding. I've also got another website where I put a lot of my research there, but I'm never up to date on the website. So my apologies for the state you'll find when you get there. And I'll start by talking about how ignorant economists have always been, because they've always equated climate to the weather. And this is from one of the very first economists to stick his nose in where it wasn't welcome, or shouldn't have been welcomed. And his statement about what's going to happen with climate change would be much worse if it happened a century ago, he says, because back in those days, most of our GDP is produced outdoors. Today, most is indoors, and therefore little is susceptible to climate. That's the starting point. Agriculture and forestry less than 3% of total output, and little else is much affected. That's where they start from. And then they make up numbers to justify this. So, and I love this particular point. If agricultural productivity declined by a third over the next half century, per capita GNP we might achieve by 2050, we'll instead make by 2051. So don't worry about the fact that half the population is starving. GDP will get there next year and they'll be fine. And then same sort of stuff. It's not at all certain that the net impact on agriculture, and according to them, that's the only thing climate change will affect will be negative or even much noticed in the developed world, pardon me. So that's a Nobel Prize winner, 2007. And he began arguing this stuff in a government policy paper 20 years earlier, which is the major reason why nothing has ever been done about climate change. Now, what they've done, having started from that perspective, that's their belief system, they've made up numbers. That's the only way to describe it. It's like your kids telling tales to explain what they haven't given their homework in. And they've made patently unscientific methods to do that. So the worst one I'll call imaginary numbers. And starting from that proposition that anything done indoors will be unaffected by climate change, here's Nordhaus in the Economic Journal, which is the original journal of economics out of the University of Oxford. Number 3 journal in the world, now by number 1 some time ago, and saying 87% of American GDP is produced in sectors that will be negligibly affected by climate change. And then he says, for the bulk of the economy, manufacturing, notice this, mining, utilities, finance, utility meaning all power and sewerage and so on, trade meaning wholesale and retail services, government as well, difficult to find major direct impacts on the next 50 to 75 years. Here's the table he published in the Economic Journal. And on the right-hand side, you can see the percentage of GDP he's talking about in each case. So those are the negligibly affected industries, 87% of GDP. Simply assumed it wouldn't be affected. Now, the other one, that's one of the original ways they try to make up numbers. The second one was to assume that what happens across space happens across time as well. And I wish I was making that up, but here we go. Mendelssohn assumed that observed variation of economic activity of climate over space holds over time as well. So you do geographic surveys about temperature and GDP, get some coefficients out of it for a function, and then you say that's what's going to happen in the future. Now, this is Richard Toll, who's one of the main defenders of this nonsense, actively defending this argument on Twitter. And he gets challenged by a meteorologist and then says, people thrive in very many different climates and some others don't. So because people can survive in any climate on the planet right now, climate change itself won't be a problem. So I've made up a little pretend way of doing this. This in fact results in a higher prediction of damages than they get themselves. But this is a pattern of temperature differences around the US average by state and income differences vertically. And fitting that with a quadratic, which is the sort of function they use, I get a damage coefficient of 0.0032, and that is actually bigger than the one Nordhaus uses. He's got down to 0.00227 times x squared, where x is change in temperature. Now, there's an incredible number of weaknesses with this. First of all, space is not a proxy for time. It's simply showing they don't understand ergodic versus non-ergodic systems to even make a comment like that. But even if it was the case, the incomes here are not independent. The income in this dot depends on the income in this dot, because these days, cold states, and these are the ones over here, make part of their income by selling stuff to hot states and vice versa. So if you really wanted to say that what happens across space happens across time, you can't allow trading, because you can trade across space, and I'm sorry, you can't trade across time. Okay? So if they'd actually taken this data and seriously cleaned it so that only stuff that was produced in North Dakota could be consumed in North Dakota, and stuff produced in Florida could be consumed in Florida, you would have got a much steeper quadratic relationship out of that data than you got out of this stuff. So they're not even doing the basic level you should do to say whether the data makes any sense. It is terribly bad work. Some of them realized that wasn't all that good. So the geniuses that they are, they decided to take existing data on change in temperature and GDP and then predict that's going to apply towards the future. Now, I think what's going on here, you've got a bunch of kids. And frankly, if these were kids, I'd be lining them up for the cane. Forget about not having corporal punishment. These guys need to have their pants taken down. They're all men, and be smashed on the backside for the garbage they've produced. They have found a database showing change in temperature and GDP for a number of countries over the 50-year period, 55 years. And they simply fitted a quadratic to that data and then said, oh, well, this shows that there's a nonlinear relationship between change in temperature and GDP. And they then extrapolated that relationship forward 80 years. You can see the grey range there is their error bar range around their median estimate. And they've simply linearly extrapolated a relationship they found between 60 and 2014, where nobody argues we'd hit any tipping points. Across the next 80 years, we are bound to hit tipping points. Now, the most extreme prediction they made is the one down the bottom here, called by Burke and Al in 2015. And that says 23% fall in GDP for a 4-degree increase in temperature. That's the most extreme prediction any economist has made. And I often get told, what about Burke? Well, it's just as bad as all the rest, because they simply say, we assume, what they say, but there's this line here, if future adaptation mimics past adaptation. In other words, if there's no structural change to the climate. Now, that's nonsense. There is going to be a structural change. This is what we call the tipping points. We want to know what's going to happen if we pass through tipping points. They're assuming no tipping points. But that's bad enough. But the fact that they're using a quadratic as well is equally nonsense. So other economists, so these are all mainstream economists, have come out and criticized them for using quadratic damage functions. Weitzman, who people thought should have got the Nobel Prize rather than Nordhaus, he attacked them for saying you're just distorting the potential dangers using a quadratic. Pindyck was quite powerful in how he said it. The damage function is made out of thin air. It's not based on any economic or any other theory or data. Okay, it's just nonsense to be using this stuff. Now, they get criticized, they nod their heads, and they do the same bloody thing again. So here is a 2021 paper, quadratic function of temperature. Even a paper looking at tipping points uses quadratics to extrapolate the data. So this is just the norm. So this paper on tipping points, which came out in 2021, said, again, if you have the idea was that it'll be damaged by temperature rise alone, and then what happens if you add tipping points to that damage from temperature alone at 3 degrees and 6 degrees. What they're saying is at 3 degrees of warming, if we lose Arctic summer sea ice, Greenland, the West Antarctic, the Amazon, the Atlantic meridional overturning circulation, the Indian monsoon, permafrost, and ocean methane hydrates. That's what they're talking about. That'll add an extra 1% at 3 degrees and 1.4 at 6 degrees, based on a second-order polynomial. In other words, another bloody quadratic. So this is typical, and to show how bad their work is and how cavalier they are about with the seriousness of the work they take in. There's what they call integrated assessment model from 1995 called MERGE. And they said MERGE places particular emphasis on the representation of non-market damages, so not things that measure GDP, but things that damage the environment in general. And they use willingness to pay to avoid that damage as a measure of how much damage has occurred to the climate. Now, this has what they call a catastrophic warming parameter, and at the point at which 100% of GDP is destroyed, and that is 17.68 degrees of current temperatures. Now, the current planet average temperature is about 14 degrees. We're talking an average temperature, night and day, North and South Pole, equator, of 31 degrees Celsius. And they say it's derived from the assumption that economic losses rise quadratically. And they're calibrated to a loss of 2% at 2.5 degrees of warming. Now, let's just dig a bit deeper and see where did all this stuff come from. Well, first of all, why did MERGE use a quadratic? Basic reason, because they're lazy. It's easy. That if damages change quadratically with temperature, the calibration requires only a single point. In other words, they're even leaving out the linear term. They're saying y is damages, x squared is a temperature change. All we've got to work out is the coefficient. And so if you say 0 damages, of course, at 0 degrees, given the fact that simply y equals x squared, you need a single point for the quadratic to pass through, and that determines the entire function. Oh, we can all go home. We've had breakfast, we can go home. Who works more than for breakfast anyway? So why 2.5 degrees and 2% damages? Well, they justified it saying that consumers would be willing to pay 2% of GDP to avoid the damages associated with a 2.5 degree temperature increase. Now, why 2%? Said, at the moment, America devotes approximately 2% of its GDP to environmental protection. Okay. So the function they derived out of that was damages are equal to 0.0032 multiplied by temperature squared. That's how sophisticated the work was to get this number. Now, that predicts that the environment, because they're not talking about the economy here, they're talking about the Holocene, let's say the actual total climatic system, not destroyed until we gain 17.68 degrees of temperature. So here's plotting it. That's their environmental damages. If we pass through the 0.2 degrees and two and a half degrees of temperature rise for 2 degrees of damages, that's where you get to. But what they're doing is they're using a percentage of GDP, in environmental spending 2% of GDP in the 1990s. Well, what was the temperature change in the 1990s? It was, let's say, roughly half a degree. Well, if you use that data point, which is empirically, that's what actually applied at the time they came up with as nonsense, then you fit that, what you get is damages of 0.08 times temperature squared. So if they'd actually been empirical, that's what they would have derived. Now that then tells you total environmental destruction at 3.5 degrees Celsius, which is probably pretty close to what's going to be the real figure. Okay, of course, the shape of approach there is nothing like what we're likely to see. It's still crazy, but that's the sort of level that scientists are describing as catastrophic. But this is how cavalier the economists are. Now, why didn't they use that coordinate? Well, because they're climate change deniers. So I've lived with this mob for 50 years of my life. I've had plenty of interactions with them. They simply believe capitalism can cope with anything, and therefore global warming can't be a threat. I mean, if there was a meteor coming, they'd use the same analysis. Okay? And this is actual quotes you can find in the literature. The one I showed you earlier was already there. Non-climate variables like labor skills, access to markets or technology swamp climatic considerations. True at the moment, not true through time. Let's see another one here. I'm not getting any. I've got to maybe chat got involved. Okay. In 1994, he did what he called a survey of experts. Those experts included Larry Summers, which I think is an incredible joke. 3 degrees of warming will be small potatoes. And this is, I'm sure Larry Summers saying this one. It takes a very sharp pencil to see the difference between a world with and without climate change, or with and without mitigation. That's their attitude. It's trivial. And then in this survey of 19 so-called experts, he had 10 economists, only 2 of whom specialized in climate change. And the other 9 are a range of different people. 3 of them were actual scientists. 1 refused to answer the questions. The 2 that did answer the questions about damage to GDP from temperature rise, their estimates are 20 to 30 times the scale of what the economists said. Nordhaus said, this is an interesting topic for future research, and never did the research. So the IPCC comes out and says the same stuff, because the IPCC hires the experts in each area. These people are seen as the experts, published in the leading economic journals, and they say the impact of climate change will be small relative to other drivers, including such things as demographic shifts. Yeah? So I really think the economists should never have got their nose in this area in the first place. They should have accepted what scientists actually have told them. And one reason why they couldn't work this out is they don't even have energy in their production functions. They can't see energy having any impact because they don't have energy as an input in their own thinking. So what they have is a standard model of production is saying production is GDP is some factor of technology multiplied by capital raised to a power times labor to 1 minus that power, which gives you constant returns to scale, which is not a bad assumption, but the only thing that makes sense in the entire equation. And the exponents here are based on the income shares of the so-called factors of production in GDP. So capitalists get about 30% of GDP, workers get about 70%. So you set alpha to 0.3, you get their standard equation that way. Now, when they put energy inside there, they simply tack it on as a third factor. So you've now got alpha, and I don't think that's mu. I don't know my Greek all that well, I'm afraid to say. And they have energy raised to the mu, well, that's 0.03. So that's roughly the size of the energy sector as the percentage of GDP. Now, what that means is with that tiny exponent, you're going to predict tiny impacts of reducing energy input. So if you had an 80% fall in energy input, that'd give you a 5% fall in GDP. I hope people are realizing how absurd that is straight away. So that's graphing that particular function for change in energy on the horizontal axis and a change in GDP on the vertical. So you go up to that point, an 80% fall in energy will cause a 5% fall in output because we'll substitute labor and capital for energy. Yeah, right. So they ignore it that way. I'm just repeating myself a bit, pardon me there. And so my point of light bulb moment actually occurred in Bob Ayres's house. Bob has just died recently, one of the leading contributors to thinking about energy. And I don't know I would have had this insight without Bob and without being in his house, which was full of statues. And walking through it at night, bathroom trip, the thought came to me, looking at his statues, labor without energy is a corpse, capital without energy is a sculpture. And what that means is energy is not an independent factor of production. It's an essential input to labor and capital. So what I did is let's produce L with labor as a function of energy, which is the number of workers multiplied by the energy each worker consumes, multiplied by how much of that energy is turned into useful work. And the same for machinery. Number of machines, energy consumption per machine, proportion that is turned into useful energy. So when you do that substitution, and I'm going to jump through this because I think I've got fairly mathematically competent people here, and B, you can look at the slide later anyway. The first bit, energy consumption of workers multiplied by how much of that gets turned into energy, into useful work, is basically a constant. Roman slaves and you and I would do the same amount. Just Roman slaves got a damn sight less energy, so far more of it was put into doing work. We get tons of energy and a trivial amount goes into doing work. That's a constant. And when you then, what you find is rather than having this mu coefficient for energy, which is 0.03, you end up with the alpha, which is the capital, which is 0.3, which gives you roughly 10 times the scale of the change. And what that means is the standard model understates the importance of energy as a factor of production. So when you do this modification, you get an 80% fall in energy rather than 5%. What you're going to get this time is 38%, because there's no substitute for energy. That's the point of saying how ridiculous it was to imagine there is such a thing. But even that's not enough, because when you take a look at the data, you find that it must be much even higher still. So even though I get a better outcome of it, here's what happens if you have a different value for alpha. And this is, I must say, I very rarely get a chance to compliment a neoclassical economist, so I'll take it. And Gregory Mankiw, whose economic textbook I can't stand, did some very good work to say that the only way you can fit the international data with a standard Cobb-Douglas production function is to have the coefficient for capital being not 0.3, which is what they use on the basis of their theory of income distribution, but 0.8. Now, once you're at 0.8, you get a much more significant impact. So 80% fall in energy, 72% fall in GDP. But in fact, the link is even stronger. And I know, again, I don't need to tell people in this audience that there's almost a one-for-one relationship between change in energy and change in GDP. That's over a 60, 70-year period. And I'm graphing them both on the same scale because the changes in energy are roughly the same as change in GDP. Now, because economists don't even have it in their brains, don't think that, they leave it out completely. And of course, what they're not aware of is that the 80% fall in energy is quite feasible, because when we'll look at the amount of energy contributed by so-called renewable energy factors, including nuclear power and including hydroelectric, we're only at about the 15 or 16% mark, maybe 17% of energy is provided by non-fossil fuel sources. So there's quite a possibility for an 80% fall in output is coming out of that. And when you look at the data, the simplest relationship is simply GDP is a linear transformation of energy. So what the school of thought that I come from, the Post-Keynesians, use when we model production is to say output is capacity utilization multiplied by capital divided by capital output ratio, where this was derived empirically by Leontief almost a century ago. And the key insight when I make this replacement here of saying let's look at capital as the number of machines times energy consumption times efficiency, you then get a description of GDP in energy terms. So there's your normal function. That's the number of widgets you produce. This is energy per widget, and that's energy as an output. And what you find is this EK is the inverse of V. So what was an empirical regularity without any explanation can be shown to be the efficiency with which machines turn energy into useful work. That's the basis of the production function and makes eminent sense. So what this means is we can now take standard post-Keynesian models, and my favorite for many reasons is Richard Goodwin's a growth cycle model from 1967. And it is empirically a sensible model. It starts off with good empirics to fit it together, to say that it does fit the data. And I've shown you can drive it directly from macroeconomic definition. So again, because I think I've got a fairly competent audience here, I won't go too slowly through this. If you define the wages share of output as omega, then you look at the rate of change of omega, which is the rate of change of the ratio. It's the difference between the rate of change of the two ratios. Do the same thing for employment ratio, the number of people with a job to the total population. You then get the rate of change of the employment rate is the rate of change of the workforce minus the rate of change of population. And if you then assume constant population growth to make a simple start to the model and uniform wages, I then do that substitution, and I use the idea of a capital output ratio as well, and use the V beforehand where I haven't yet substituted the EK, and assume that capitalists invest all their profits, which is how Goodwin first built the model. What you get is a very simple differential equation model of a rate of growth in employment and rate of growth of wages share of GDP, and it gives you predator-prey cycles. So if you run it, you get the same cycles you get out of a predator-prey model, uniform cycles all the time. Now, what I'd say, well, let's actually take this and substitute the EK argument, and then what you've got is a model for production in terms of energy. And this actually makes empirical sense because the correlation coefficient between energy and GDP at the global level is 0.997, and the correlation coefficient for change in energy and change in GDP at the global level is 0.83. Sorry, not correlation, R squared. So the correlation is pretty much 0.9, okay, or larger. So at a first approximation, GDP is energy turned into useful work. And that's where we should be starting. So you then have the Q I defined earlier, the Y I've defined so far. Do your substitutions. Again, I'm repeating myself a bit here. So you get the substitution for useful work is 1 over V. And what you get is an energy-based model. So rather than a V over here, I've got times EK. That's the only change that is necessary. And what you get is, of course, the same dynamics. But what you can do is now link it up to resource depletion and pollution, because you're using energy to do this. You can have an energy stock you add to the model, and this is showing it in total terms rather than ratios over here. You get a cyclical model. And Kerry was talking about my software beforehand. If you want to run that model, you can go to SourceForge, download Minsky, and then when you click on it, it'll bring up the model and you can run it dynamically. I'll quickly show that. I won't take too much time. But what I've got going on here is physical output as well as waste being generated. And I've got resource depletion reducing how much energy stores you have to work on. So ultimately the system collapses. So if I want to run this with Minsky, I can run it dynamically and see how it's behaving. And I'm seeing that, but I don't think you are. Maybe you are. Maybe you're good. I'm seeing two screens here. So you can see the cyclical behavior of the model. Yeah. So I won't keep it going because I know we have time limitations courtesy of another talk that Kerry's got to give. So I'll keep on going there. Now, that's just seeing it as a role of energy. And as a first approximation, it's bloody good. You could do that and say, for a simple model, GDP is energy converted into useful work, and run with that as your explanation for capitalism. But of course, we know we also transform materials. So the main form which we consume, that energy, is how it transforms matter. So how do you bring matter in there as well? And how can you, and to do it at a single commodity level, this is the first thing. Most economic models, which is a mistake, that most models stick at being a single commodity. You imagine there's something you use to consume, there's something you use to make capital goods, the same good, a universal good called a widget. Now, how do you explicitly imagine that? The first person to try was John Hicks, who was a person who made a very big mistake early in his life and corrected it fairly dramatically later. He began as a neoclassical, he ended up as a post-Keynesian. But he attempted to do this way back in 1937, or 33, I think it was, 35, pardon me. with a paper called Wages and Interest, the Dynamic Problem. So he tried to build a dynamic model. And he said, let's assume a community producing and consuming a single homogeneous good. And he called it bread. And that makes sense. You can eat bread. They said bread is made by the cooperation of labor and capital goods, which are not homogeneous. Yeah? And he kept on going and tried to make it work. But he finally said, well, machines are dated bread. That means you can take a stale loaf of bread and make a fresh loaf of bread. I'm sorry. This doesn't make sense. And so they ended up actually out of this, he produced a dreadful model called the ISLM model, which led economics astray drastically. But it was a valiant attempt at the time, but he blew it. And the conceptual problem is it's easy to imagine bread as a consumption good, but how the hell do you imagine bread as an investment good? It just doesn't make sense. So thinking about this, I had the brainwave in working with Matteo Scriselli and Tim Garrett of turning to cartoons, because you may know the movie called The Iron Giant. Now, the Iron Giant came from the planet on which you eat iron. I thought, well, what about if you imagine iron as the consumption good, as well as the investment good on the planet of the Iron Giants? And then it makes sense. You can actually get away with it and say, I'm modeling the cartoon. So you've got an imaginary world where the workers consume iron. And they also use iron to make capital goods. And they have to, of course, they've got to mine energy. They've got to mine iron ore, and they've got to smelt the iron ore and turn it into iron ore plus slag. So that was the model. And then you mold it as well. So you can actually conceptually think of a world consisting only of iron, so long as you, rather than making a crazy substitution on the investment good, you make a crazy substitution on the consumption good. And that actually got us to solve it. So you have energy mining, iron ore mining, and iron ore smelting and rolling. And you have three sectors, and they've all got to use energy as a motive force. And we've only worked with the ratio here, but you then say energy output is the number of machines in the energy sector times the energy consumed in the energy sector per machine, times the efficiency of conversion, times the conversion ratio. So the first one is energy return on energy invested. The next is iron ore return on energy invested. Then you have massive iron ore. Then you have the factory sector also giving a return. But here's, of all things, the conservation law came to our assistance. How do you do the manufacturing side of things? You know there's conservation of matter and energy. So the amount of matter you put in is the amount of matter you put out, and you can weigh both the iron and the slag in terms of the weight in kilograms, and that must be equal to the input weight in terms of iron ore. So you have conservation of energy going on there. The energy used in those sectors must be the energy produced in the whole sector. You have conservation of matter. So what's going on there has to keep the amount of kilograms of iron ore into kilograms of iron and kilograms of slag. So that's how we did our aggregation. We said total capital is the weight of machines in the energy sector times the proportion that the energy sector machines make up of total weight of capital. So there's tons of machines, number of machines, and the weight of the weight each machine weighs. And you then, how do you get the whole thing to balance? This is where we cheated. So I'd like to have somebody take this on as a PhD topic and do what we didn't do. Rather than saying the needs of the mining of the factory section determine the yields of the energy in mining, let's have a price system and dynamics inside that area as well. So we made all these assumptions to enable us to force a conclusion here. And what you then get, the ratio, the energy yields for energy and mining are determined by the need of the factory sector. And so you can then do these various conversions. And what you got was Goodwin again, okay? But Goodwin now in terms of a multiple input, single commodity output. And what you're getting is the production of both iron ore and waste, or iron rather than waste. So you get the same classic cycles. And again, I could model that in Minsky if we had time to go through it. So what I see, this is a potential foundation for doing a multi-commodity dynamic input-output model of capitalism with production in terms of energy and multiple, I should have had non-commodity inputs there, commodity inputs, but also non-commodity inputs, the essential raw materials. So that's what we should have been doing. That's where economics should be. Why didn't we do it? Who led us astray? Okay. And I found people will talk about Milton Friedman, Robert Lucas, maybe Hayek, et cetera, and talk about crazy assumptions they made and so on. I think it's Adam Smith, because you go back and read The Wealth of Nations. This is the very opening sentence to the book: the annual labor of every nation, blah blah blah. Okay, I'm going to jump on because I've got a comparison. But you can compare that sentence to the opening sentence of Richard Cantillon's An Essay on Economic Theory, written just 21 years before Smith wrote The Wealth of Nations. And he says land is the source or matter from which all wealth is drawn. Okay? Now you look at Smith. He's simply substituted labor for land. Okay. First of all, it looks like plagiarism. You can find the imitative statements here. There's land and food and conveniences of life. There's labor and necessaries and conveniences of life. Okay. But the most important thing, he substituted labor for land. Now, the problem is that the physiocrats, and Cantillon belonged to a school of thought called the physiocrats, which died out in the late 1700s, preceded the classical school. They saw the source of wealth as what they call the pure gift of nature. So they said, wealth doesn't come from what we do. Nature gives us wealth for free. We simply transform it. So in a fundamental sense, they understood the laws of thermodynamics. And here's Turgot, who puts it beautifully. Nature grants the physical fertility of the soil, nothing to do with humanity. The labor of the husbandman, their term for the farmer, produces more than he wants. He can with this superfluity that nature accords to him as a pure gift. That is the first law of thermodynamics, long before it was actually invented, a century ahead of time. So they're saying wealth originates with nature outside the economy, whereas Smith is saying the source of wealth is labor, which is inside the economy. And then you had, as a result of this, the value laws, which I'll talk about in a moment. So speaking from a physical point of view, the fundamentally correct ones are the physiocrats, because you can put their views in terms of the laws of thermodynamics. Now, I know, again, I've got an audience here that knows there are laws of thermodynamics, unlike economists. But this is for quoting Sir Arthur Eddington, who was the Stephen Hawking's of his time, popularizing Einstein's views as well as doing his own research. And he said, look, if you have a theory that contradicts Maxwell, that's Maxwell's problem. Of course, that was Planck. If your theory doesn't hold up to empirical observation, well, maybe there's been a mistake in the experiment. But if your theory is against the second law of thermodynamics, I can give you no hope. There is nothing for it but to collapse in deepest humiliation. Now, in that sense, Smith is inconsistent with the laws of thermodynamics, and so have all economists been since then. I hate to sound egotistical here, but until my paper with Bob Ayres and Russell Standish in 2019 on the role of energy in production. Now, most social scientists don't even know those laws exist. And there's a classic illustration of this from a physicist who was also a playwright, C.P. Snow, wrote a book called The Two Cultures. And because he was a recognized novelist and also a recognized physicist, he would often move in both circles. And he said, when I'm talking to my artistic friends, they'll be saying how illiterate scientists are. He said, every now and then I thought, okay, how many of you can explain the second law of thermodynamics? You got a cold and negative response back. He said, but what I was asking is the equivalent of, have you read a work of Shakespeare? And most of them had no idea. So I'm not an expert, but just to remind everybody of the laws here. The first law being conservation, you can neither create nor destroy energy. The second being, my nickname for it is degradation, entropy rises. And the third I call degradation. You can't be 100% efficient unless you can find somewhere that doesn't exist, which is at the temperature of absolute zero. And the beat poet, if you want to explain this to anybody who's outside the science realm, the poet Allen Ginsberg put it beautifully, like a game of cards. You can't win, so why would you play? But he said, you can't even break even. Why don't you leave? Well, you can't. You can't get out of the game. Those are the laws. And you apply it to economics, you get production can't occur without inputs from nature, and especially energy. You can minimize waste, but you can't get rid of it. And there's no surplus. Economists, and particularly in the classical school, talk about a surplus as if labor can produce more output than it gets as input. But no, we're not doing that. We're taking what exists in nature. We're putting a bit of energy in ourselves. So energy return and energy invested matters. But that's where we get our potential to live from. Without the sun, we wouldn't be having this conversation or anything else. So it's the free gift of nature that lets us have a productive system. And the physicrats were right. They got it right. Smith led us astray without realizing he was doing it. He was really sort of being realistic and saying, well, this doesn't explain surplus in manufacturing or production in manufacturing. Manufacturing is productive, so it must be labor. So it was an enormous mistake in terms of its consequences, but not one that would have been even obvious to Smith when he first made the mistake. So what he implied was that workers produce a surplus because he had workers producing more than their wages. Otherwise, how can you have a profit? And he didn't manage to explain it. The first classical economist who gave an explanation that made sense within the framework of the classical school was Marx. Now, Marx, by doing that, turned the classical school of thought from being a supporter of capitalism to a critic of capitalism, which is where the neoclassicals came along with their idea of the marginal productivity theory of value. Now, they're both wrong. We've spent a quarter of a millennium arguing over them. And we're all, as a result of that, the post-Keynesian school I come from is rather different because we're driven by a desire to be empirically accurate. But fundamentally, the core principles in economics have been wasting their time for a quarter of a century, because a quarter of a millennium. So the question is, why hasn't economics reformed itself? And I highly recommend reading Max Planck's autobiography. He said at one point that his own experience in physics, he could never persuade anybody to accept his argument who was a Maxwellian physicist. They said the reason things progress in science is their opponents eventually die. That's where the famous phrase, science advances one funeral at a time, comes from. Now, it could happen in economics as well, but it doesn't. So what's wrong? It doesn't advance one funeral at a time. We're still stuck with ideas that were wrong 150 years ago. And I think what you look at is, why did it work, say, with Ptolemy's model? Because you had this idea of, that they could easily predict where Mars was going to be in 200 years, but they had a totally wrong model of the universe. And what you got as a result was errors accumulating over time. And that ultimately forced the importance of changing the paradigm. But it meant things like, for example, if you wanted to explain comets, the only explanation you could allow within the paradigm is that they're atmospheric phenomena, because they can't come from the heavens, because heaven is perfect. So, weird disputes like that come up, but along comes Halley's Comet, predicted by Newton's mathematics, and that confirms the Copernican view, and bang, that's the end of the Ptolemaic astronomers. Not that they converted to Copernicus, but nobody listens to them anymore. Now, what you get out of this is the potential for science to undergo revolutions. If you haven't read Thomas Kuhn's The Structure of Scientific Revolutions, put that on your reading list for the weekend. It's a brilliant piece of writing, very short, only about 160 pages from memory, and beautifully put explanation of how science undergoes revolutions. So if you start with the idea of an ether through which light has to pass, you then have the Michelson-Morley experiment that shows there is no ether. You then get relativistic and quantum explanations for light traveling through a vacuum. Your pre-relativity scientists, as Max Planck said, can't accept it. They continue teaching the old idea, but the students have got to put up with the old codgers, know of the Michelson-Morley experiment, and they can do it themselves if they like. They know it's there all the time. So the students are putting up with the old fogies teaching the old ideas, but knowing that for them, their future success will come if they can solve that dilemma. Now, eventually, the old scientists have to retire or die. The students who are committed to a new paradigm come along and right, day one, I'm going to start teaching Planck. Okay, and therefore, that's how science progresses one funeral at a time. So it's a punctuated process. You have an established paradigm, an anomaly. Established scientists resist it. They can't persuade the students to ignore the anomaly. A new paradigm comes along. The old scientists die. The students take over. Paradigm change occurs. That's what happens in a real science. But in economics, we don't have the generational change mechanism. Firstly, the anomalies in economics, you can ignore them because they're either empirical And hands up to anybody who remembers the Great Depression. They're not repeated. You can't run them again and see what happens. New events come along and they take over the whole story. And theoretical failures, like, for example, what's called the capital controversies, which neoclassicals lost hands down, and Paul Samuelson conceded defeat in 1966. And the very first paper I read to point out that what I was being taught was nonsense in the mainstream. And he finally says in the final paragraph, if this all causes headaches to those nostalgic for the old-time parables of neoclassical writing, we must respect and appraise the facts of life. Okay, we've got to accept change. Well, they didn't do it. They continued teaching this garbage even after Samuelson conceded defeat. So what you have is adherents to the existing paradigm want to ignore the anomaly, and they can forget it over time, and they do. And a new generation comes along. So some students and people, I'm an obvious example, say, well, this doesn't make sense. If you can't explain the Great Depression, then you don't have a worthwhile theory of economics. So Hyman Minsky developed what we call the financial instability hypothesis as part of that, but he was rejected by the mainstream. And you remain marginalized, you never replace the neoclassicals, and economics remains pre-scientific. And one of the main things here, the neoclassical paradigm is a very seductive vision of capitalism. It's a meritocratic world. You get paid your marginal product. You get paid what you contribute. It's a fundamentally utopian, anarchist interpretation of capitalism. And in that sense, these guys are zealots for a world, a perfect world that they're trying to bring about on Earth. And that's why they're so damn dangerous. So the old paradigm keeps on going. They ignore the anomalies. Critics become parts of heterodox schools, like I am. We eke out an existence somehow. I'm now supported by crowdfunding rather than the proceeds of my Nobel Prize. Work in a shithouse unit, pardon me, I was told not to swear, wasn't I, Kerry? These work out in low-rank universities, you get in business schools, etc., etc. So the revolution doesn't occur. And you get absurd assumptions made to ignore anomalies. That's what I call the neoclassical disease, and I discussed that in great detail in the New Economics Manifesto. So I would plead any economic students here.
A couple more minutes, Steve.
Huh?
Just a couple more minutes. We can get to a couple of questions.
Yeah, sure. Okay. Learn complex systems. Learn system dynamics. You do a lot more study to get your work you want to do, but please do it, because at some point there's going to be a day of reckoning for neoclassical economists, and they deserve it. So, and I'd also a bit of advertising there. Consider signing up for my online lectures. And at that point, I'll stop sharing and let's chat.
Okay. Thank you very much, Steve. So we'll go to a couple of questions that people submitted. Still, please submit some if you have some. One, I'll perhaps just kind of read off here. I think it's a sort of a good question. Would you argue a failure of economics to adequately capture risks and potential damages of climate change? So more the first part of your talk was more due to which of the following: number one, inherent epistemological issues, biases or lack of diversity or limited worldviews of economics. Two, just tools and analytical method approaches that aren't well equipped to model damages. So are the issues you brought up having to do with sort of economic theory and fundamental ideas, or are they just a bad idea for climate damages?
I think it's two causes one. Okay, because if you start with the wrong tools and the wrong methodology, then you're going to make mistakes on the epistemology as well. So that's why I took it right back to Adam Smith and said you could blame Nordhaus alone. I mean, I really do want to blame Nordhaus. I mean, I want to blame Nordhaus to the stage of having him sued for ecocide. I think he's going to destroy potentially billions of humans and God knows how many other life forms out of the bad work that he's done. But he wouldn't have produced the bad work if they hadn't used the wrong tools to begin with, which is where the mistake to leave energy out comes in the very first instance. So if we began with the physicocrats, rather than resisting the physical sciences, economics would have been a century ahead of the physical sciences. They would have had the concept of entropy and the conservation laws before they became part of physics. So we lost that much. We lost a century. And I think I put two first, but then one turns up, because once you've got that mistake, everything else will turn up.
Very well. Okay, thank you. Another question. You kind of answered this, but maybe you can elaborate. How do we use the so-called, let's just call it the physiocratic perspective, as you're pointing out, to make a better economic model to address different challenges we face in economics. So perhaps you can redefine or just to summarize the physiocratic perspective, which may be conservation of energy and mass. I don't know. Go ahead.
Yeah. Well, the starting point for the first cuts was that agriculture produced the surplus, and that was a vision. If you live in a very rural society, which is what France was at the time, as well, very much a French school, then you plant one seed, you see 1,000 seeds come up. You know it's not your labor, it's the land you're putting it into. So it's very easy to see that there's no surplus due to your labor. It comes from nature, and it's a free gift you're exploiting. So that then means you have an argument that we have to take the gifts of nature and transform those into useful goods for ourselves. You're already talking about energy. Before the word energy was invented, energy was only made as a word in 1809 by an English polymath, I've forgotten his name, but they would have preceded that by 30 years or 50 years. So that's the starting point. I would then actually use, of all things, Marx's theory of value, not the labor theory of value, which is a huge mistake by Marx, but his dialectical theory of value. So if you search what's called the Friedegaard lectures, you'll find my explanation of what Marx's philosophy was. It's dialectics, not what you would have heard, the standard stuff they give about thesis, antithesis. Synthesis is not Marx, and it's a useless term anyway. But Marx gave a very sensible philosophy of change, which could be the foundation for talking about the overall dynamics of capitalism. And you work in complex systems, nonlinear dynamics, chaos theory. It all fits in very nicely from a physiocratic starting point.
Let's see, the question, the failure of traditional macroeconomics, perhaps meaning neoclassical, seems to be evident all around. It doesn't work for well over 75% of the global population. So in the face of this failure from this questioner, why do we continue to teach this? I guess you ended slightly on this note of, but maybe, yeah, anything more on teaching? Not enough people teaching other methods? Not enough.
The heterodox people teach realistic stuff in low-ranked universities and publish in low-ranked journals, and we never get enough momentum, or we don't get the community that you need to really produce a critical mass of alternatives. So this lot, they just self-referential. The goal of an economist is to be all regarded by other economists, and because they get well funded. You know, you've Harvard and Columbia and Princeton pay far better than Kingston and Western Sydney, and they just reproduce their own stuff. And it's a religion. Yes, I'll put the slides available, by the way. Definitely, I'll pass them on to Kerry later. But yeah, it's taught because they believe it, and that's exactly the same thing that happens in a church.
Right. Okay. So here is another question. Thanks everyone for submitting. Do you think integrated assessment models are misrepresenting the cost of decarbonization, given they don't evaluate the interactions between energy and GDP? So question one of two. Second, would you expect the cost of decarbonization to be higher or lower than maintaining the current energy mix? So capabilities of current integrated assessment models and energy. Go ahead.
The models are dreadful. I mean, these are supposed to be models talking about economic growth. Two of the major ones, Page and Fund, so Chris Hope's and Richard Toll's model, don't have economic growth in the model. They take it exogenously. They feed in economic growth as an input outside the model. Well, that's garbage modeling to begin with, even without looking at the rest of it. And they fit into their own crazy numbers. So they're totally useless. They're worse than useless. They're dangerous. They've deluded us into, I think we're into one of the cusp of environmental catastrophes, thanks to models like this. To the cost of decarbonation could have been a damn sight lower if we'd started doing it when the limits to growth wanted us to in 1972. Their preferred point to start trying decarbonisation was 1975. So the cost would have been far lower. Now it's going to be astronomical because 85% of our energy still comes from fossil fuels. So if we're going to try to survive that, it's going to be a cost in terms of physical output. If we have to go to zero carbon at the moment, we face an 85% fall in GDP, if we're lucky. So I think we're going to be forced to a period of non-capitalist distribution. If we're going to hold societies together, you need rationing. And that is a complete destruction of capitalism. It's like a war economy. So I see the cost being extremely high, but it's because of the delays that neoclassical economists caused.
Okay, right. Thanks. Let's see. Yeah, I guess here's this other question asking about the slides, but the second part is where would you point to your work that has the most complete discussion of your economic model and predictions or how it works, any forecast for real world economies like the United States?
Yeah, I've spent most of my life fighting bloody neoclassical economists, so I developed the models, but I haven't had a chance to apply them empirically properly. My 1995 paper called Finance and Economic Breakdown in the Journal of Post-Keynesian Economics, that's where I first predicted potential for a financial crisis after a period of apparent stability. So I predicted not just the, I didn't predict in terms of numerically fitting the data. There was no data in the model. It was all a mathematical model extending Goodwin's model to include finance. And it said, if you have a period of diminishing cycles in this model, the outcome on the other side is rising cycles, and that's a warning of a crisis to come. So that's why I predicted the financial crisis. You find plenty of empirical fits that I do these days. The basic argument I make is that credit is a fundamental part of aggregate demand and income. And when you look at the data, that's where I give quite a bit of that work in my lecture series. And in my most recent book, the New Economics and Manifesto, I put the data inside there, and change in credit gives its correlation with unemployment levels is minus 0.94. So I basically say, if you want to see what's happening to the economy, look at credit, and that'll answer the question for you. The best person doing sophisticated versions of my models now is a guy called Tyrone Keynes. And if you come on a YouTube channel on a Saturday called Steve Keen and Friends, Ty runs that channel, and you'll see some of his work, and it's magnificent. He's really pushing what can be done with Minsky to marvelous levels, better than I can do. So I think there's also work by Matteo Scriselli and a couple of others using my models to predict American economic dynamics. So people have been using them, but again, we're a minority. We never get the time to do the proper research. It's working on the smell of an oily rag doesn't give you a Nobel Prize for two reasons.
Right. So the challenge to those of us trying to make better models is to actually calibrate them to the real world and simulate some results. So okay, we'll keep working.
Yeah.
It seems as though the research, I guess this questioner is referring to the economics research you mentioned, was intentionally designed to produce the results that, quote, climate change doesn't matter. By and large, the economists are inclined to continue, economists are inclined to continue down this path. Would you agree with this general statement? Do they?
Yes, completely. You've done both very accurate statements. I have written a report for a group called Carbon Tracker. It's on my website, it's on my Patreon page, and on my Substack. All my posts are free access. I'm delighted to get more support, but to try to change the nature of economics, I put all my posts up there for free. And you'll find that my report for Carbon Tracker begins with a survey of economists by mainstreamers, where they interviewed every economist who published, or surveyed all economists who published in the top 25 economics journals, 2,200 people. 740 answered the questions and 350 answered a particular question on what's going to happen to GDP given this temperature trajectory. And the median prediction they gave was that 3 degrees of warming by 2050 will reduce global GDP by 5% compared to what it would have been in the absence of climate change. So we're still talking about GDP growing for the next 28 years, and by outright at 7 degrees by 2220, so 2 centuries away. And they said that'll cause a 20% fall in GDP. Now, when you translate that prediction in a future decline, because you've got an exponential function, the change in the rate of growth that they're predicting from climate change up to and including 7 degrees of warming is a drop in the rate of growth of 0.02% per year, which is one fifth of the accuracy with which statisticians currently measure actual GDP change over time. So they're saying it's trivial. That's what they're doing. And they wanted to dismiss it all the way through because climate change involved, if you actually took it seriously, it meant controls on what capitalists can do. And this is a religion that says capitalism works best with no controls. So therefore, climate change can't be a problem. That was their mindset.
All right, here's another question. We'll try to get through a couple more here. You went through an excellent exercise to prove energy should have been included to model damages. However, the cause of damage, climate damage, I think, isn't energy as much as carbon-based energy. So would you not need a model that decouples carbon emissions from energy to best model these costs?
You would, but I mean, Tim Garrett, my good mate Tim Garrett, the atmospheric physicist from University of Utah, makes the point that we haven't been decarbonising. We've been adding non-carbon energy sources on top of carbon. So yeah, you want to separate the two. We should have been separating the two from 1975, trying as much as we could to reduce the amount of carbon we generate. That was also under limits to growth. So yes, you should, and that's a major issue. So some colleagues are working on very simple models, including what they call green versus brown energy, and then how fast can you make the transition from brown energy to green energy. And most of those models say, given the fact that we're currently only producing 15% roughly of energy needs using green energy, the transition has to involve a massive fall in GDP.
Yeah, to the questioner, I'm trying to solve your problem as well. And maybe we'll end on this one here. I think your ultimate assessment of the outlook of world economies is going to a sort of wartime distribution and non-capitalistic distribution is likely. What will the effects of the debt generated from the previous decades have on this? Will it be ignored, or what are the consequences of debt at the current moment?
Great question. Yeah. First of all, government debt doesn't matter. Government debt is the mirror image of government money creation. During the Second World War, we had a dramatic increase in government debt, which is actually how much fiat money was created to finance the war on all sides. Every country produced fiat money to produce the armaments and run the battles. Thank God the Allies won, but it was the same monetary production system behind the military production system that determined the outcome of the war. But the private debt's the issue. And again, during the Second World War, private debt fell dramatically as a ratio of GDP because people were being paid large amounts of money, including firms. They couldn't spend and consume goods. They were only producing stuff for the military and the factories, so they paid off their private debt. So a major reason why the post-Second World War boom occurred was private debt had been driven down from the astronomical levels that it reached during the Great Depression to relatively trivial levels, and you had a debt-free takeoff at that stage. Now we're encumbered with debt again. So once we get this happening again, I think the same thing will occur. The private debt's going to disappear, and you don't want anybody going bankrupt and being told you can't work when you want as many hands as possible to be, trying to convert what happens with climate change. So I can see at least it'll eradicate the private debt. But why do we have to go through world wars and climate catastrophes to get rid of private debt in the first place?
Right. Okay. Well, maybe we'll end it right there. So thank you again, Steve King, distinguished research fellow at the University College of London. Thanks for joining us on the UT Energy Symposium, teaching us about economics.
Welcome, Matt. Good to see you.